In terms of how economists work, we tend to kind of look at data first. We have some stylized facts, is what we call it. So we kind of look at facts like, oh, what does the data look like? But that is not serious empirical analysis. So it's kind of like graphs that you see on the newspaper or whatnot. Once we see some facts, that seems like in the data, it seems to be true when you kind of draw some diagrams, some data out. Then we kind of go into theory. Theory is what economists are mostly about. We try to understand what is causing the data to look like that. What are the channels? What are the mechanisms? What are the formal models? And we come up with different stories. Now, economists kind of write formal stories to explain different things, and that's what theory is. That's why we use a lot of math that brings the formality into it. But then we kind of go back and say, okay, now that we have all these stories, can we figure out which story is actually true? And this is where the empirical analysis comes back again in the form of econometrics, where we use data to kind of see which story is true and which story is not true. And once we kind of get fairly comfortable that some of these models or theoretical models or stories seem to be truer in the data than others, that's when we kind of move to policy and kind of say, okay, now if the policymaker wants so and so, this is the way to do this, because we kind of understand how this works. So this is generally how economists work, and this technique can be used to pretty much answer anything. I have an example here, does money buy happiness? And we can try and answer that. So, so using this example, we would probably want to kind of get a whole bunch of different data sets. Because without empirical data, if you can remember what I just said, without some kind of facts, some kind of data, we really don't start forming stories. We need to have some data. And data can come in lots of different forms, shapes, and sizes. There could be time series, there could be cross-section, there could be panel. Now, to answer the question, does money buy happiness, we can have all kinds of different kinds of data. So let me talk about these three particular ones. So the first one, this one is what we could call, say, a cross-sectional data. And the idea here is we're looking at a bunch of units, so the persons, so person one, person two, person, so each one is a unit, or each observation is a unit. And we're looking at the information of their income and their happiness, right? And I'm looking at the data for the same year. So we are looking at a cross-section of individuals across the exact same time period. So this is what we mean by cross-section data. So units of observations are multiple. Number of time period is 1. So I'm looking at, say, only 2001. I did a survey. I asked a whole bunch of people what their income was, and I asked a whole bunch of people, those same individuals, what their happiness was. How do I have a number for happiness? Well, I could have asked them, like, on a scale of 1 to 10, 10 being very happy, 1 being least happy, how happy would you say you are? So we could do some version of that. So cross-section data, a bunch of units of observation, but the same exact year. And you can see there's a whole bunch of variables we're collecting data on. The variables in this data set are income, age, and happy. Okay, so units of observations are person, number of time periods is 1, it's 2001, and number of variables are 3, income, age, and happy. Now, instead of collecting cross-section data, we could also have collected time series data. So we could have followed the same individual, person one, same individual. So this is Jack, Jack, and Jack, and followed them over a bunch of different years. So number of time periods are higher, more time periods. And I could see as their income changes, what happens to their happiness. So this kind of data set is called time series. A similar kind of data set could be, what if I collected data on the price of gasoline in the United States over the last 10 years? So the unit is the United States. The variables are the price of gasoline, and then I'm collecting it over a whole bunch of years. So that's also time series. Macroeconomists tend to use a lot of time series data. And the third kind of data, so there's definitely way more, but the third kind of data that's also popular is what we call a panel data, where we use a bunch of different units of observation. So person one, person two, person three, so lots of different units of observation. But I'm also using different time periods. So I'm following a lot of people, a lot of units of observation across a lot of different time periods. So 2001, 2002, 2003, for example. And this is, in some sense, the better data set, right? So we are not just looking at one person like in time series. Also, we're not just looking at a bunch of people over one particular year. I mean, what if that particular year was a crazy year? That would probably not be a good idea to just look at that particular crazy year. So It's not a cross-section, it's not time series, it's kind of like the combination of both. And in general, economists, when they look at empirical data analysis, they tend to like panel data sets, analysis based on panel data sets, much more than cross-section and time series. Now, I want you to think a little bit about what these three types of data sets are, and why would you want to use one kind of data set in your analysis over another? What are the strengths and what are the weaknesses? All right, so let's talk a little bit about this. Now, time series. Time series kind of follows the same unit over time. And so say you are interested in figuring out what makes Jack happy. Well, if you are interested in figuring out what makes Jack happy, maybe the best thing to do is to follow Jack over time. Why would you want to follow Jack and Jill and Henry and Robert and take an average of that to figure out whether money makes Jack happy? When you're interested in just Jack, it may actually be a good idea to follow Jack over time to get a better feel for it. So that's a good place for using time series. Why would you use cross-section? Well, the reason you would use cross-section is when you're not really interested in just Jack, you're saying in general, just does money buy us happiness? So then you want your Jack, your Jill, your Robert, your Carolina, Caroline, you just want pretty much every single person, a general group of randomly sampled people. And that would be a good one for cross-section. Now, what could go wrong with cross-section? We already said, what if it is a very particular year that you collected the data, and that particular year was a bad year? It was the Great Recession year, or it was the year where COVID-19 kind of spread. And so with these kind of examples, things can, the cross-section data might give you spurious results, or wrong results, which is not true for other time periods. So you have to be careful about that. But oftentimes you want to use cross-section and not time series. The last one is panel. And panel kind of is good in the sense that, okay, it's a whole bunch of people and it's following them over time. So you're not stuck with one particular time period where things were crazy. But the thing with panel is, the weakness with panel is, well, if I'm really interested in Jack, it's the same argument for time series. Why the heck would I want to look at every single person out there or a whole bunch of other people? We would probably just want to do time series. So depending on what is the question that you're trying to answer, you probably want to consider sometimes time series, sometimes cross-section, and sometimes panel. But if you want to answer questions in general, does money buy happiness, probably panel data set is the best thing to use. Okay, so next time you look at any article or you read something and they have some data, ask yourself the question, what kind of data are they using? Are they using time series, cross-section, or panel? And is this the best one to use to answer a certain question? You may hear things like external validity. So oftentimes a study might be done in China or in India or US or Argentina. And then the question is, what we find here, is this valid in a different country? So if you did a study in the US and you're talking to US policymakers, that study is great. But if you're going to go talk to somebody in Germany and say, hey, the study was done in the US, well, you may want to worry about the external validity of the study done in US as it applies to Germany. So that's the kind of thing you want to think of. Also, remember, most of these analyses, especially panel and cross-section, are talking on the average. They're not talking about exceptions. So don't use anecdotal, exceptional examples to say an average result is wrong. When a cross-section or a panel is used, they are trying to answer the question as, on the average, what can we expect? All right. Here's one example I'll leave you guys with. That'll be kind of fun. Here's some data to look at the relationship between happiness and income, so real income per capita. This is data collected from the US. Look at this data and see what you think. Take your time. See what, does it seem like more money buys you happiness? All right. So if you kind of worked on this, you can unpause now and kind of look at it. What we're seeing is, this is, first of all, time series data, because we are looking at US and we are using two separate variables, happiness and income, over time. So it's the same country over time, and this is average happiness and average income. And as you can see, this darker line, which is basically happiness, seems to be pretty stable. It's being measured as somewhere between 2 and 2.5, and it's pretty flat. But if you look at GDP per capita, or income per person, it has been rising a lot between 1973 and 2003. How much has it risen by? It went from roughly to 20,000 per person to 40,000 per person. And this graph is taking into account inflation and price changes and all of that. It has taken into account all of that. That's crazy. Income per person almost doubled, but happiness did not seem to change on the average. So this is also known as the Easterlin's paradox, something that was used to kind of start happiness economics. And there's been a lot of, so this is a stylized fact that is kind of saying it doesn't seem like there's a relationship. And since then, there's been a lot of theories trying to explain why this is the case. You should try and think about some yourself. But if you use the cross-section data, the time series data for US to kind of look at this, it seems like there is no relationship. Now, what if we looked at a slightly different data set? Take a little bit of time to look at this. This is average happiness of countries and average income per person of different countries at a given period of time, and see what kind of relationship you see. I'll give you a few minutes to think about it. All right. So hopefully what you did see was, if this is income per person and this is happiness, you may have seen some kind of a quadratic relationship or whatnot, but generally you saw there seems to be a positive relationship because of this region, right? So the higher the income per person, higher is the average happiness. And this seems to tell you the kind of slightly different answer. It says, no, money seems to, or a higher income per person seems to buy happiness. And this was actually a paper, a bunch of following papers with these kind of analysis went back and said, hey, this Easterlin paradox is not even true, because there is a relationship and that's not the right graph. But then, of course, economists had to try and make sense of why did we get the two relationships, and there's a whole bunch of literature about this we can talk about. Now, the things to take away here is, by the way, you'd realize this is cross-section data. Hopefully you do, because this is for a particular year, a bunch of units. Now, the thing to take away from here is that based on the kind of data you use, notice you can get very different results. So you have to be very careful. And the best thing to do is to look at all kinds of different studies. So this one seems to be true for the US, but that doesn't mean this is going to be generally true for all the countries. And so this is saying on the average, and this is kind of saying what is true for a country. So that kind of explains why we could get very different results. There's a lot of stuff you can read about this, and if you're interested, get in touch and I'll be happy to help you out. But be very careful about these visual evidences. They are a starting point for most analysis, but they're under no circumstance the end point of any analysis.